The universe is 13.8 billion years old, filled with billions of galaxies, each containing billions of stars. So why is it that in all that time, not a single alien has knocked on our door, left a message, or even waved hello? Where is everybody? This is not science fiction. This is the most profound question in science, the Fermi Paradox, and the answer may be far stranger than you think. When we consider the question of whether we are alone in the universe, we are confronted immediately with a paradox that has puzzled scientists for decades. Given the sheer scale of the cosmos, the vast number of galaxies, stars, and planets, how is it possible that we have seen no definitive evidence of intelligent life beyond Earth? This is the essence of what is known as the Fermi Paradox, named after the physicist Enrico Fermi, who famously asked, in the middle of a lunchtime conversation, "Where's everybody?" It's a question that is simple to state, but extraordinarily difficult to answer, because it forces us to reconcile two starkly conflicting truths. On one hand, the universe is unimaginably vast, almost incomprehensibly so, and teeming with the raw ingredients for life. On the other hand, despite decades of searching, scanning the skies, launching probes, and listening with radio telescopes, we have yet to detect so much as a whisper from another intelligent civilization. Statistically, this should be impossible. If life is probable, and if intelligent life arises given the right conditions, then the cosmos should be noisy with signals, messages, or artifacts from civilizations far older and far more advanced than our own. Yet, in practice, it is silent. This juxtaposition of high probability and low evidence forms the heart of the Fermi Paradox, and contemplating it invites us to probe deeper into both the nature of life and the structure of the universe. The paradox compels us to examine what we mean by life and intelligence, and to distinguish between the two. Life itself, in its most basic form, may be common. Microbial organisms could be proliferating in environments that are currently beyond our technological reach. Moons like Europa or Enceladus, planets within the habitable zones of their stars, or even subsurface oceans hidden beneath ice layers could host life that is biologically complex but not technologically communicative. Yet, intelligence, that spark which allows a species to manipulate its environment, to reason abstractly, to create technology, is far less predictable. Evolution, as we understand it, does not guarantee intelligence. Natural selection favors traits that improve survival and reproduction, but intelligence beyond what is necessary for survival can be a rare, emergent property. In our own solar system, life may have arisen multiple times in microbial form, yet humans remain the sole species capable of building radio telescopes, sending spacecraft to distant worlds, and developing mathematics to decode the universe. This implies that even if life is common, intelligent life may be vanishingly rare. The universe could be filled with tiny, thriving ecosystems scattered across countless planets, yet civilizations capable of interstellar communication might be few and far between, appearing briefly and disappearing before overlapping with one another in space or time. The consideration of time complicates the matter even further. The universe is 13.8 billion years old. Stars, galaxies, and planetary systems have been forming and evolving over nearly incomprehensible spans of time. Civilizations might rise and fall in a cosmic blink, existing for a few thousand years before succumbing to self-inflicted disasters, natural catastrophes, or other unknown factors. Humanity itself has existed for a fraction of a second on the universal clock. If intelligent life tends to have such brief windows, the chances of two civilizations existing simultaneously close enough in space to detect one another are extraordinarily small. We might be among the earliest intelligent species to arise in a region of the galaxy, scanning the skies for others who simply do not yet exist. Alternatively, we could be latecomers, appearing long after other civilizations have already vanished, leaving behind only traces too subtle for us to detect with our current instruments. The timing of our existence in this sense is as much a factor in the Fermi Paradox as the spatial distribution of life. And it reminds us that intelligence is not only rare but ephemeral on cosmic timescales. Moreover, the paradox challenges our assumptions about probability and expectation. It tempts us to think that because something is possible, it must have occurred frequently and therefore should be observable. But the universe does not operate according to our intuition. The cosmos is immense. Distances are vast, and the physical limitation of space travel and communication impose significant constraints. Even if intelligent civilizations exist, they may be separated from us by hundreds or thousands of light years, making their signals weak, delayed, or indistinguishable from cosmic background noise. The probability of coincidence of alignment between our technological capability and the presence of a detectable civilization is astronomically low. Yet, the Fermi Paradox forces us to confront that very low probability, compelling us to explore not only the existence of life, but also the methods, limitations, and biases inherent in our search for it. The question of whether intelligent life is rare naturally leads to reflections on why intelligence itself might be a scarce outcome. Evolution is contingent, not deterministic. It is shaped by random mutations, environmental pressures, and historical accidents. On Earth, for example, life existed for billions of years before complex multicellular organisms appeared, and even then, intelligence in the sense of reasoning, tool-making, and technological innovation took millions of years to develop. There is no guarantee that any other biosphere, no matter how old or chemically favorable, will produce a species capable of advanced cognition. Conditions that favor life are not the same as those that favor intelligence. It is possible that planets can host thriving ecosystems for eons without producing a single technologically communicative species. Our own existence may therefore represent a confluence of rare events, an extraordinarily improbable outcome of chance, evolution, and environmental stability, making intelligence, in the grand cosmic context, an exceptional phenomenon. The rarity of intelligence also frames the way we interpret the universe around us. If intelligent civilizations are uncommon, the silence we observe is less surprising. The absence of signals does not necessarily indicate absence of life, but rather absence of civilizations capable of transmitting detectable messages. This subtle distinction is important. The universe may be alive in ways we cannot immediately perceive, filled with organisms and ecosystems thriving quietly on planets and moons, yet devoid of societies capable of constructing telescopes, sending spacecraft, or broadcasting radio waves. Our current observational technology is biased toward detecting the kind of life that mirrors our own, intelligent, and technologically advanced. We may be missing the vast majority of life because it communicates differently, exists in forms we cannot yet identify, or is confined to scales, microbial, chemical, or environmental, that elude our instruments. Furthermore, considering the scarcity of intelligence introduces profound philosophical implications. If intelligent life is rare, then humanity occupies a privileged position in the cosmos, a species with the capacity to understand, explore, and perhaps eventually travel beyond its home planet. This realization brings with it both responsibility and humility. Responsibility to use our intelligence wisely, to preserve our fragile biosphere, and to cultivate the knowledge and technology necessary to endure over cosmic timescales. Humility, because it reminds us that the universe does not center itself on us. Our existence is contingent, fragile, and extraordinary precisely because it is uncommon. The silence of the cosmos, in this context, is not a reflection of neglect or oversight, but a mere highlighting our uniqueness and the challenges inherent in surviving and thriving as an intelligent species. Finally, exploring the possibility that life may be common but intelligent. Life rare encourages a re-evaluation of our search strategies. We must recognize that our expectations are often shaped by anthropocentric assumptions that life must be similar to ours, that intelligence must follow a predictable path, and that technological communication is universal. Yet biology on Earth demonstrates tremendous diversity, suggesting that evolution elsewhere could take forms we cannot currently imagine. Intelligence may manifest in ways that do not produce signals detectable with our current instruments, or in temporal windows so fleeting that the probability of overlap with our own existence is minimal. Understanding these limitations refines not only our search for extraterrestrial life, but also our comprehension of life itself, pushing us to broaden definitions, develop innovative detection methods, and appreciate the profound uncertainty inherent in exploring the universe. In sum, the Fermi Paradox forces us to confront both the probability and rarity of intelligent life. Life may well be widespread, existing quietly on countless worlds, Yet the emergence of civilizations capable of interstellar communication is not guaranteed. Evolution is contingent, timing is critical, and intelligence may be an extraordinarily rare outcome of complex interactions between biology, environment, and chance. The silence of the cosmos, far from being evidence of emptiness, is a reflection of these probabilities and constraints. It challenges us to reconsider our assumptions, expand our understanding of life and intelligence, and marvel at the improbable. Emergence of our own species within a universe that is vast, old, and full of mysteries yet to be discovered. As we move deeper into the question of why we haven't found aliens yet, it becomes clear that intelligence itself may be an extraordinarily fragile and fleeting phenomenon. The universe, in its immensity, does not guarantee that a species capable of creating technology or sending signals will survive long enough to make itself known. History on our own planet offers a cautionary tale. Humanity has developed tools and knowledge capable of remarkable achievement. Yet, we are simultaneously capable of self-destruction. Nuclear arsenals, climate change, ecosystem collapse, and pandemics illustrate how easily a civilization can destabilize itself once it achieves the technological capacity to manipulate the environment at a global scale. When we extrapolate this pattern to other civilizations, the picture becomes stark. Intelligent life may be common enough to arise sporadically throughout the cosmos, yet civilizations might almost inevitably destroy themselves before achieving interstellar communication or exploration. The silence we observe may not be evidence of absence, but of a pattern repeated countless times over billions of years. Life flourishes, intelligence emerges, and then, before it can make contact, it disappears into history, leaving only traces that are extremely difficult to detect across the vast distances of space. This possibility leads naturally to the realization that even if civilizations do exist, the signals they produce might never reach us. Space is unimaginably large, and the distances between stars, let alone galaxies, impose severe constraints on communication. Electromagnetic signals, radio waves, for example, spread out as they travel, diluting in intensity according to the inverse square law. A signal broadcast from a civilization 1,000 light years away would be unimaginably faint by the time it reached Earth, potentially indistinguishable from the background noise of the cosmos. Our own attempts at listening have been limited both in scope and in time. Radio telescopes have scanned only tiny fractions of the sky at specific frequency, and the universe itself continues to evolve and change while we monitor it. Even if someone, somewhere, had sent a signal, the timing might not align with our period of observation. Civilizations may broadcast intermittently or in directions that simply do not intersect with Earth. In this sense, the silence is as much a product of distance, timing, and technological limitation as it is of the rarity of intelligent life. What we perceive as absence may, in fact, be the consequence of our nascent observational capabilities. Timing, indeed, is a critical factor. The emergence and survival of intelligent civilizations occur on time scales that may be brief relative to the age of the galaxy or the universe itself. The universe has existed for nearly 14 billion years, a span so vast that human perception struggles to comprehend it. A civilization might exist for only a few thousand or tens of thousands of years, a blink of an eye on the cosmic clock. Even if 1,000 civilizations arose within our galaxy over billions of years, the likelihood of any two overlapping in time and space to the extent necessary for communication may be extraordinarily low. We could be early, witnessing the first stirrings of intelligence, or we could be late, arriving after previous civilizations have vanished. The galaxy could have been, and may yet be, teeming with life, whose epochs of existence never intersected with ours. This temporal mismatch provides a natural explanation for the silence, emphasizing the importance of considering both spatial and temporal scales when contemplating the distribution of intelligent life. Another intriguing possibility is that advanced civilizations might deliberately avoid making themselves known, a concept sometimes referred to as the cosmic zoo hypothesis. Highly intelligent species could have learned that survival in the universe requires discretion, choosing to remain undetectable to minimize risk from other civilizations. The universe is not inherently dangerous, but interactions between civilizations capable of interstellar travel could produce conflicts with catastrophic consequences. Perhaps the most prudent strategy for longevity is silence, a conscious decision to observe without being observed. In this scenario, the apparent emptiness of space is deceptive. The galaxy may be populated with civilizations that are deliberately hiding, either from us or from each other, in order to avoid conflict or interference. The idea is counterintuitive because it challenges our anthropocentric expectation that intelligent beings would be curious and communicative by default. In reality, survival strategies may favor invisibility over interaction and discretion over broadcasting one's existence. This introduces the concept of observational bias in our search for extraterrestrial intelligence. Humans have a tendency to expect that life will behave in ways familiar to us, that it will follow similar evolutionary trajectories, and that will communicate using technologies and methods we understand. Yet the universe is likely to be far more inventive and diverse than our imagination allows. Civilizations might employ communication methods that are entirely alien to us, signals encoded in neutrinos, gravitational waves, or exotic energy forms that we have not yet detected. They may communicate over timescales and frequencies beyond our current technological reach. By assuming that other intelligent life mirrors our own, we constrain our expectations and risk missing evidence that is already present, hiding in forms we are not yet capable of perceiving. Our silence may therefore reflect limitations in our understanding of observational capabilities rather than a genuine absence of life. The challenge of detecting extraterrestrial intelligence is further compounded by the nature of cosmic evolution. Stars are born and die, planetary systems evolve, and the conditions that support life may appear and disappear over geological and astronomical timescales. Even if intelligent life arises, the window in which it is detectable may be fleeting, constrained by environmental changes, catastrophic events, or technological obsolescence. The galaxy is dynamic, and civilizations must contend not only with their own internal challenges, but with the broader cosmic environment. Gamma ray bursts, supernovae, and asteroid impacts all pose risks that could erase or obscure the traces of civilizations before their signals ever reach other stars. In this way, the interplay of internal and external factors further narrows the likelihood of detection, emphasizing that the absence of evidence is not necessarily evidence of absence, but may instead reflect the fragile, transient nature of technological civilization. Finally, reflecting on the rarity of intelligent life offers a profound perspective on humanity itself. If advanced civilizations are indeed rare or ephemeral, then our own existence assumes a level of significance, not in a cosmic sense of specialness, but in terms of opportunity and responsibility. We occupy a unique moment in the universe's history, endowed with the capacity to study, explore, and understand the cosmos in ways no previous species has. This awareness carries with it the duty to safeguard the conditions that allow our civilization to persist, to extend our knowledge, and to continue the search for life beyond Earth with rigor, patience, and creativity. The silence of the universe challenges us not only to look outward, but to reflect inward, to recognize the fragility of intelligence and the preciousness of the window of opportunity in which we exist. In contemplating the scarcity of advanced civilizations, we gain a deeper appreciation for both the vastness of the cosmos and the remarkable chance that we have to be here, asking questions, seeking answers, and expanding our understanding of life in all its potential forms. One of the most important factors to consider when pondering the silence of the cosmos is timing. The emergence and lifespan of intelligent civilizations are not guaranteed to coincide. The universe is nearly 14 billion years old, a timescale that dwarfs the entire history of human existence. Even on a galactic scale, stars and planets have formed and perished in cycles that extend for millions or billions of years. A civilization capable of interstellar communication may exist for a few thousand or perhaps a few 100,000 years, a cosmic blink. When you compare this to the lifespan of the galaxy itself, it becomes obvious that two civilizations might never overlap in time. Imagine a species that rose on a planet in the Milky Way 2 billion years ago and disappeared long before humans even walked upright on Earth. Its signals, if any were broadcast, would have dissipated long before we developed the technology to detect them. Likewise, civilizations that arise in the distant future may find Earth silent, because we have already passed from the cosmic stage. The galaxy is not static. It is a dynamic arena where stars, planets, and civilizations flicker in and out of existence, often without ever intersecting. This temporal mismatch is a compelling reason why we may not have detected extraterrestrial intelligence yet. Not because it is absent, but because the timing of our existence may simply not coincide with theirs. Understanding this forces us to confront the vastness of time itself and reminds us how brief and delicate the window is in which intelligent life can interact across the stars. Even if civilizations do exist at the same time as us, the universe is immense, and communication is not straightforward. The distances between stars are so vast that even light, traveling at nearly 300,000 kilometers per second, takes years, decades, or millennia to traverse them. A signal sent from a civilization on a planet orbiting a star hundreds of light years away would have taken centuries to reach Earth. And by the time it arrives, the civilization that sent it may no longer exist. This raises an additional layer of complexity. Advanced civilization may be broadcasting in forms we are not yet capable of detecting. Humanity relies primarily on electromagnetic signals, radio waves, microwaves, and more recently, laser pulses, but these are only one of many possible communication methods. Other civilizations may communicate using techniques beyond our current understanding, encoding information in neutrinos, gravitational waves, or energy patterns that we have not yet conceived. Our technology is still in its infancy relative to the scale of the universe. We are listening with an ear trained to detect signals in a tiny fraction of the spectrum for a fraction of time. And with instruments that cover only small areas of the sky, in effect, we are trying to eavesdrop on a conversation conducted in languages we do not speak, over distances that are almost incomprehensible, using instruments that are only just sensitive enough to detect the faintest whispers. Another intriguing possibility is that intelligent civilizations choose to remain silent. The universe, while not hostile in itself, is a place of unknown risks, and any civilization that survives long enough to develop interstellar technology may have learned that discretion is an effective survival strategy. Broadcast your presence too broadly, and you might attract unwanted attention. The consequences of contact with another civilization, one perhaps more advanced, could be catastrophic. In this sense, civilizations may practice cosmic restraint, deliberately avoiding signals that could expose them. If this is true, then the apparent emptiness of space is misleading. The galaxy could be teeming with life, yet largely invisible because its inhabitants understand the value of subtlety and the danger of discovery. It is a sobering thought that intelligence might be both a blessing and a liability, that survival in the cosmos may favor those who remain hidden, observing quietly rather than revealing themselves. The universe, in this view, is populated not by a loud chorus of voices clamoring for attention, but by a careful, cautious network of observers who have learned that silence is safer than exposure. The challenges of detection are compounded by the sheer limits of our current observational techniques. Humanity has scanned only a minuscule portion of the sky at a tiny fraction of possible frequencies, and for an extremely short duration relative to cosmic time. Even if an alien civilization has been transmitting signals consistently for millennia, we may have missed the window in which those signals intersect with Earth. Additionally, we must recognize the limitations imposed by signal degradation. Electromagnetic waves weaken as they spread through space, encountering interference from cosmic background radiation, interstellar dust, and other celestial phenomena. By the time a message traverses hundreds or thousands of light years, it may arrive as a barely detectable fluctuation, indistinguishable from the noise that permeates the universe. Detecting it requires not only highly sensitive instruments, but also a degree of luck, alignment in frequency, timing, and location. Our current capabilities are sufficient to begin the search, but they are far from exhaustive. The universe, in its immensity and complexity, remains largely unobserved, and it is entirely plausible that signals exist that we have simply not yet noticed. This scenario also forces us to confront the limitations of our anthropocentric assumptions. We tend to imagine that intelligent life elsewhere would think, behave, and communicate in ways familiar to us, yet evolution on Earth alone demonstrates the incredible diversity of life and cognition. The principles of survival and adaptation could lead to forms of intelligence radically different from human reason, expressions of thought that do not manifest as technology, or communication modes that are completely alien to us. The universe may be filled with civilizations that are intelligent in ways we cannot recognize, expressing themselves through means that are invisible to our current methods of detection. Our search, in many ways, reflects our own perspective rather than the totality of possible existence, highlighting the need to expand both our imagination and our technology in the quest to understand life beyond Earth. Contemplating these factors, timing, the vastness of space, deliberate silence, and the limitation of detection yields a humbling perspective on the nature of the universe and our place within it. The apparent absence of extraterrestrial civilizations does not necessarily indicate their non-existence. Instead, it reflects the immense challenges inherent in establishing contact across cosmic scales. Civilizations may exist yet remain undetected because of distance, transient lifespan, technological limitations, or the deliberate choice to avoid exposure. In this context, the silence of the universe becomes not a source of despair, but a prompt for reflection, curiosity, and continued inquiry. It reminds us that understanding the cosmos requires patience, imagination, and humility, and that the pursuit of knowledge is as important as the answers we seek. The very act of searching, even in the absence of contact, illuminates the profound complexity of life, intelligence, and existence in a universe far larger and stranger than we can easily comprehend, even as we grapple with the enormity of space and the fleeting nature of intelligent civilization. We must acknowledge that our search methods are still in their infancy. Humanity has only been listening to the cosmos for about a century in a meaningful way, and during that time, we have barely scratched the surface. The electromagnetic spectrum is vast, spanning frequencies from long radio waves to high-energy gamma rays, yet our instruments cover only a tiny fraction of this expanse. Moreover, the universe is dynamic. Stars, planets, and potential signals are constantly in motion, meaning that the sky we observe today is not the same sky we will observe tomorrow. Signals may pass through our observational reach like fleeting shadows, detectable only if we are looking in exactly the right place, at exactly the right time, with exactly the right tools. The challenge is compounded by the fact that intelligent life may not even use the same forms of technology or communication that we rely on. Humanity's experience is but one tiny experiment in evolution, and assuming that others would develop radio waves, lasers, or other familiar methods of signaling is to impose our own history onto the cosmos. We must expand our imagination and our instruments simultaneously, exploring ways to detect life that may express itself in forms completely alien to us, whether through chemical signatures in exoplanet atmospheres, unusual energy patterns, or phenomena we have yet to conceive. Our assumptions about communication, grounded in human experience, may be the very reason we have yet to detect extraterrestrial intelligence. We tend to think in terms of sending messages and receiving them of civilization, actively trying to communicate in ways we can interpret. Yet the universe may contain intelligent life that has no interest in outreach, or whose concept of communication is fundamentally different. Imagine a species that perceives time in millennia rather than decades, or a species whose consciousness is distributed across a planet, or even across a star system. Their methods of interaction might be subtle, slow, or inscrutable, leaving no obvious markers for our instruments to detect. Even civilizations attempting contact may broadcast using forms of energy that dissipate quickly or require technologies far beyond our current understanding to recognize. It is a sobering thought, but it highlights an essential point. The silence we perceive is not necessarily an absence, but perhaps a reflection of our limited perspective and technology. The universe may be teeming with intelligence, yet it remains hidden from us because we are not yet equipped to perceive it. The vastness of space, combined with our technological limitations, brings into focus the extraordinary patience required to search for life beyond Earth. Humanity's observational history is brief, a single heartbeat in cosmic terms. We have launched probes to neighboring planets, scanned the skies with radio telescopes, and analyzed exoplanets for signs of habitability, but these efforts have only begun to map the cosmos with sufficient detail. The scale of the endeavor is almost incomprehensible. Even if a civilization exists 1,000 light years away, their signals may have been traveling toward Earth for centuries, and we may have only just developed the ability to detect them. The universe operates on timescales that dwarf our own, and our search strategies must account for this. Embracing long-term observation, patience, and the continuous development of more sensitive instruments. This perspective transforms the apparent emptiness of space into a reminder of the immense challenge before us. and simultaneously of the remarkable achievement that is our ability to look outward at all. Beyond the technical challenges, there is a profound philosophical lesson embedded in the silence of the cosmos. The absence of obvious alien civilizations encourages us to reflect on our own species, our fragility, and our place in the universe. If advanced life is rare, then humanity occupies a unique position, a species capable of conscious inquiry, technological innovation, and the potential to explore beyond its home planet. This realization carries both a privilege and a responsibility. We are the observers, the curious, the first to ask questions that may never have been asked elsewhere in the galaxy. We have the opportunity to extend our knowledge, to preserve our civilization, and to contribute to the understanding of life as a universal phenomenon. In a universe that is vast, indifferent, and governed by immutable laws, our curiosity itself becomes a defining trait, a reflection of intelligence in action, and a bridge to the possibilities that lie beyond our world. The silence challenges us, but it also motivates us to continue searching, innovating, and contemplating, for the act of inquiry is itself a testament to our existence. The universe may also teach us humility through its apparent emptiness. It is tempting to project human desires onto the cosmos, to expect it, to be crowded with neighbors, eager to communicate or to make contact. Yet the laws of physics are indifferent to these expectations. Life, intelligence, and communication arise under contingent circumstances, subject to environmental constraint, evolutionary chance, and the vast distances and timescales that separate stars and civilization. Recognizing this compels us to appreciate our own existence in a deeper way. The fact that we're here, capable of asking these questions, capable of building instruments to scan the heavens, and capable of imagining the lives of other beings across the galaxy, is itself remarkable. Our civilization is a rare and precious phenomenon, a testament to the interplay of chance, necessity, and persistence. The silence of the cosmos, far from being a void, is a canvas upon which the story of intelligent life, including our own, is written, often subtly and often in ways we have only begun to perceive. In contemplating the challenges of detecting extraterrestrial life, the vastness of the universe, the limitations of our technology, and the potential rarity of intelligence, we are reminded of the critical importance of perspective. Humanity's search is not merely about finding company in the cosmos, it is about understanding the conditions that allow life to arise, to persist, and to reflect upon its own existence. Each observation, each scan of the sky, each study of distant worlds is a step in a process that spans generations, civilizations, and epochs. The universe does not respond to impatience. It unfolds according to its own laws and rhythms. By cultivating patience, curiosity, and technological sophistication, we increase the likelihood of eventually detecting signals, artifacts, or traces of other intelligent beings. Even the absence of evidence contributes to knowledge, guiding our methods, refining our expectations, and challenging us to think beyond our own biases. The silence is a lesson in humility, a call to expand our minds and instruments, and a reminder that exploration is as much about the questions we ask as it is about the answers we hope to find. Finally, the endeavor to find extraterrestrial intelligence is a reflection of humanity's broader quest to understand its place in the universe. The apparent absence of other civilizations teaches us about our responsibility both to our own species and to the broader cosmos. We are, at least for now, the stewards of intelligence in our corner of the galaxy, capable of observing, analyzing, and reflecting upon the vastness that surrounds us. The search for aliens is therefore inseparable from the search for meaning, understanding, and continuity. Each telescope we build, each signal we analyze, and each exoplanet we study is a testament to human curiosity and persistence. In the face of silence, we are compelled not to despair, but to explore further, to refine our methods, and to appreciate the fragile, fleeting, and extraordinary phenomenon that is intelligent life. The universe is vast, and the cosmos may be full of life that we have yet to perceive, yet even in our silence, we are participants in a grand experiment of observation, imagination, and discovery that may one day reveal that we are not alone. So, after exploring the vastness of the universe, the fleeting nature of civilizations, the challenges of timing and distance, and the limits of our own technology, one thing becomes clear: the silence of the cosmos is not necessarily evidence that we are alone. It may reflect the immense scales of space and time, the rarity of intelligent life, the fragility of civilizations, or simply the fact that we are still learning how to listen. The universe is far larger, stranger, and more complex than our human intuitions can grasp. And yet in that silence lies an invitation to explore, to observe, to question, and to marvel at our own existence. Humanity's curiosity, our ability to reason and to search, is itself a reflection of intelligence in action. And it is this curiosity that drives us to look up at the stars and ask the profound question, are we alone? Thank you all for joining me on this journey through the cosmos, for contemplating the mysteries of life and intelligence beyond our world, and for daring to imagine the possibilities that lie out there among the stars. Keep looking up, keep questioning, and never stop exploring.